Hello everyone, and welcome to the next installment of the Quick Start stuff on using the MQTT. This one is specifically about the web application development with MQTT. It's, like I said, a continuation of what we did with we had a part one where we specifically brought up ESP8266. If you remember, I'm not sure if everybody was here the last time. This is a Node MCU board which has some code in it. We were doing for the first quick start where we set it out and configured it to talk to the Austin IoT MQTT program. So we're going to continue that. In this case, we're going to do the opposite side. We're going to use the WebSocket interface side of the broker to talk to our web application. So we can then write applications that talk to our devices. So how many people here are familiar with JavaScript programming in a web browser? A few? How many of you have done programming in C or any other language? Okay, pretty much everyone. All right. So if you've done programming in pretty much any language, especially any language that's related to C, you won't have any trouble following along with any of the stuff that's going on here. This document and the other one are both in my Bitbucket repo under UC Hobby. So you can open it up there and follow along. It's got links to the previous, well, just look at the one that says Web MQTT Quick Start. So to use this thing, we're going to work with the Git CLI, which is just the Git repo management tool from the command line. We're going to use a simple web server so that we can set up an environment on our own PC to do all our working with. Once you have something working, you can deploy it to an image server and make it accessible everywhere. But it's best to work right on your own desktop. And this tool is very nice, you can see. We're going to use an MQTT JavaScript client library. We're going to use the broker, which is an Austin IoT. And I like to use the Microsoft Code Editor, Visual Studio Code. It works great, and you'll see some tricks that I use when I work with that editor. But I usually put this in these quick starts. These presentations and all the code are free for you to use. I hope it serves as a good starting point for your own projects. Okay. So the first step, you obviously need a place to work. So I'm going to do this as if I was starting from scratch, following this guide, so that you see that everything here works. And so what I'm going to do is go create a directory. I've already got one created, but I put it on my C drive called the Austin IoT directory. Okay? And so the trick I'm going to show you is you're going to get a command prompt at a directory you see in Explorer. You just type, you highlight the address bar, and you type CMD, and you'll get a command prompt. So now we're in that prompt, and I'll come back to that in a minute. They talk about instructions. The instructions here talk about where you can get, and then do a clone of the repo. Okay? So I'm not going to install Git while you watch. You just have to trust me that those instructions work. Then you can get Git installed very easy. But this command right here is the command you type on the command line once you get installed. So I'm just going to copy it out of here, go to my command line and paste it. And what it'll do, if you have Git installed, is it'll go grab the repo and pull down all the files. So you'll have an exact copy of this repo. In fact, if you have an account and you set things up, you can edit it and make changes. The changes won't be approved for me to go onto the web, onto the main repo, but you could do a pull request. If you know how to use Git, you can set it up so that you can make changes and then suggest that I pull them in. And then I could integrate them if I wanted to, or if I thought they were good. So I now have made this directory here, and you see that there's an MQTT quick start in it. So we're going to change that directory. So that's where all our files are. Not wet. So then you see there's a bunch of files in other directories. Now the next trick I'm going to show you is if you're using Visual Studio Code, you can instantly open it on this directory with all the files open, ready for your project working. So we can see we're going to do, before I do that, I'm going to follow the instructions. I'm getting a little ahead. What we need to do is install a simple web server, step 2. So in step 2, I'm assuming you have Node installed, but you'll need to install Node. It says so right here. And once you have Node installed, you can follow the instructions at this, where this says here to install the light server. Okay, so I'm going to do that now. It's very simple. I should have typed the instructions in there. npm install. Actually, because I already have this done, you see there's a file called package.json. It's very easy. You don't even have to do the install manually. You can just type npm install. That all by itself will do everything it needs to be done. So this command takes a few seconds, but it's actually going to go out to the web and grab all the dependencies that are required for the project that you just pulled there.
And that's all in your package file.
It's all specified in the package file. I can show you that. I think I had a note to show you that. So Node.js, I'll go ahead and follow my little guide here. So these are the points I wanted to talk about. Does everybody here know what Node.js is? Does anybody, I guess most people don't. Okay, so it's pretty awesome. It's something you should go research if you want to do web application type development. It is my way, it's what I consider, if you say you're going to do mobile application development, that to me means Node running on a server somewhere and a client running it as an application in the browser on the device. So that's a web application. So the back end is usually supported by Node, and the front end is JavaScript running in your browser. That was delivered by a server running in Node. So Node is the server side of a web application development. Now, what Node really is when Google created Chrome, they created a virtual machine engine to run JavaScript that was in the browser, and they called that V8. And V8 sped up JavaScript 1,000 times. Okay, and that's the first time they did it. It's since gone another magnitude greater than that. JavaScript is not a trivial language anymore. It's very fast. It's a reasonable language to work with. It's not an interpreted language. It could be interpreted, originally it was. But V8 just in time compiles it. So when you load a JavaScript application, it gets compiled to native code by the V8 engine on load. So you're not running really slow code or anything. There's already, AutoCAD has application, for doing drawings with running JavaScript in a browser. So this is the future. Node.js is definitely a major player in application development, and if you're going to get into that, you should study it. It's very easy to use and work with. Yes?
Another one of the huge benefits of Node over the conventional Apache or LAMP stack is that in a LAMP stack, every request spawns a new child process instance of the Apache server, whereas in the Node.js environment, it's just a single process that listens and executes in what's called an event loop. So you can handle like orders of magnitude more concurrent requests using comparatively minimal resources.
Yes.
Node is the bomb.
Node.js, when you work in Node.js, you become familiar with asynchronous programming. It's very much an asynchronous programming. It works on a message loop as opposed to normal threading programming. So it's very stable. It's an exceptionally stable environment. It pretty much can handle whatever you throw at it. It's very good. Highly recommend it. npm is a Node package manager. It's a tool that's like having a if you're familiar with Linux, if you know what apt-get is, or any of those package managers. So for the video, they're doing some work in the back, and it's a little bit of noise there as they doing some work in the back of the room. Anyway, so npm is a package manager. All the stuff you want to install, packages like if you want to talk to a serial port, if you want to make a web server, if you want to do talk to MQTT, any of those kinds of things, you will use the npm package manager to install that library. And what we did here is we have a, I'm going to go ahead and show you this next trick. So I'm on a command line in my directory. Now, all the stuff you see displayed here is the work the package manager did to to install this components that are necessary for this development. As
Is there any way you can make that bigger?
you probably want the text larger, as opposed to just bigger, right?
Yeah. Better.
If that helps any.
Yeah, that's good there.
So you see it installed a bunch of different components, because it knew that the simple server that we installed, actually the light server we installed, needs other pieces installed. And if you look now in this directory, all we've done is done a pull from my repo, which brought us the package.json file. And then we ran the npm install. So now there will be a new directory called Node modules. You see it there? So Node modules, the only thing in there is light server that you can see. But that's where the modules go that you install for Node. They'll end up in there and it just magically work for you from that point forward. Okay, so the next trick is how do you get code out of it? You type code in a space and a dot, and it will open up the code Visual Studio Code Editor with all the projects ready to be viewed, right, and all the stuff is so now, I'm going to show you that package.json file real quick. So here's the package.json file. It's a file that as a developer, when you create an application that uses Node, you create this package file. And then when you distribute your application, you just distribute your source and the package file. And when the user installs it, he just drops the files into the directory he wants it and he runs npm install. Install will go grab this and look at what it needs and figure out what components it needs to install to support the application. So you see here down here where it says dependencies. The dependencies say light server, a version that's roughly 1.3.1 or greater. So there's codes, a lot of that up caret means and things, but in general, it's telling the npm package manager that your application needs this server. Okay. Once we've done that, we have the web server. It also tells, there's also a command here that tells for the command line for npm how to start your application. It's another neat thing about npm is that the person who created the application can give you all the details to start it and build it into a script in npm. So the start command. So if we type npm start, npm is actually going to find that script and it's going to run it. It's going to start the server, and you see the server started up there and then it opened a web page. So that's all scripted by the web server. But you can see here is where it came up and it's telling us what our web server is at and what ports it has. So this web server is a pretty nice little machine. It has it also has a let me go back to my quick start. So first web page, here I tell you to run npm start, we just did that. I say open index.html from step 3. What happened when it loaded the index.html that's in the root. So here's my directory here, my structure. There's an index file right there. That's the one that the thing loaded automatically. I tell you in the steps to go to open this one.
So I got a question. So what you showed before, what you're showing now was JavaScript?
I haven't showed any JavaScript yet.
What was, because the other thing looked different, it had, the package thing has the brackets and all that, so what is this?
No, this is JSON.
JSON, okay.
So JSON stands for JavaScript object notation.
Okay, all right.
So it is JavaScript, but technically it's the code, it's just data.
Okay.
So this loads into the npm manager as an object that it then parses and does the work with. Yes.
In many ways, JSON is a replacement. You can do the same thing you can do with XML.
Yeah,
Only a lot nicer than XML.
Yeah, a whole lot nicer. Lot
XML
cleaner.
is more self-defining than JSON is though.
Yeah. So now what we want to do is go to our browser and get it open on step 3. So we can shortcut here. I got a shortcut for you. So we're on step 3. And all that does is prove that we've got a web server running and we can get to a web page, okay? All right, that's all we've done so far. The objective in this quick start is to walk through step by step so that if you hit a flaw, you know where to look. It's a simple thing. Your web server's not running if you didn't get this. Hopefully I explained that in the troubleshooting steps. Yeah, I did. So step 4, I say, I ask you to go edit the file. I want you to edit the step 4 in the, to open this file in the browser and in the editor, and then edit it. And you'll see some of the magic of this little server when we do this. So I'm going to go ahead and go open step 4. So step 4 is running, and all it's got is it's got a title and a single line of text in the web page. You can see here and here. And then I say in the tutorial to go change some code on that. So here, step 4, I say change this. So we're going to say okay, so now I'm going to save this. And so the minute I save it, it will automatically update in the browser. This is not as easy as, not as cool to see when it's on where I have to switch the windows. But if you have a bigger monitor, you have both of them up simultaneously. What's really cool is you can edit, and every time you save it, instantly updates including the JavaScript, the CSS, no matter what you change. As soon as you change it, it updates automatically in the browser. So it's very nice. You don't even have to go click refresh.
Can you autosave too?
Well, the browser, the two things are separate. So if your editor autosaved, every time it did that, we triggered the page to reload.
Do you have to use the Chrome browser when you're doing this? It can be any browser.
My recommendation is that you use the Chrome browser by default because it supports everything. It's the most up to date most of the time. Internet Explorer is very close now. Firefox is almost as good. But so your apps, you can make them work in all the browsers, but you could run into little subtle differences. And I'm going to show you why you really want to use Chrome. Did you have a question?
Well, I was going to make a minor correction for you. Edge is close to Chrome. Internet Explorer still isn't.
Yeah. Yeah, technically it's called Edge.
Yeah. Well, they are.
Well, no, they have both
separate.
on 10.
They are two separate entities now, completely separate from one
Why are
another.
they doing that?
Yeah, but I think the legacy IE versions are going to die, aren't they?
Well, they're sticking around specifically for enterprise users because they have legacy applications that they won't update. So it
But
allows
read
you to
that
still
as
run the old
they had
ones.
code they had to break to work with Internet Explorer.
Yeah.
They don't want to fix the code that works properly yet.
Right.
IE8.
Yeah. So anyway, so what he said. So what I recommend you use Chrome simply, and we're going to show you here in one of the next steps because it's built-in debugging. So all the major browsers have good debuggers now, but Chrome kind of leads the pack in that domain. So we're going to move forward.
Followed by Firefox and Firebug.
Firefox is exceptionally well good at this as well. So we did our edits, and we confirmed that our changes occurred in the browser. And I make a note that if you use the lens service, it'll happen automatically. You don't need to refresh. So real quick, just in case people here don't know, aren't up to speed with everything in HTML, I just want to point out that this is just a generic HTML document. The first line specifies that it's HTML. Its doc type is HTML. This is the way you specify an HTML5 now. So it used to be there was a more complex line there, but it's been simplified down. And so we just have the HTML body. The header is with a title in it, and the body with a single chunk of text. It's not even got a tag, so not even got tags around it. Technically, that should have a paragraph tag around it, but it's okay. And we edited that and saved it in the server. What our web server is doing is HTTP is really just file transfer. It's just a very, very simple file transfer designed for small files. And so when you open a web page, what you're actually doing is telling a server to grab a file for you and deliver it to you. And so this file is what's being delivered, and the HTML is what the browser renders. Okay? So then we're going to go on to step 5. If any questions at all, if I'm not, if you're not keeping up with me, please slow me down. I get excited and I'm going really fast. So now it says open step 5, index in your editor. And then click the button to verify JavaScript works for you. Open the, I should have those in opposite order. But I'm going to go ahead and come over here and just do it manually. So I'm just going to go over here and edit step 3 and go to step, wait, step 5? So step 5. So this page is a little fancier, just a little bit fancier. There's quite a bit of stuff has changed. We'll go through that, but the objective here is to prove that your JavaScript is able to run in your whatever your environment is. So if we click this button, it's going to print a line up there that puts the time. So what's happened is we've created HTML that has a button on it. It is an event handler, and that event handler runs and will updates a portion of the page called the DOM to put in this string of text. So if that happens, JavaScript works, your browser works, your web server works. You've gotten up to the point where you can pretty much do, you can do development now. You should have all your tools, your editors, everything's all working at this point. Okay, now we're going to get, we're going to get a little bit fancier now. But I'm going to explain here this stuff that I got highlighted. So, step 5, index HTML. So you see what we added here is we've added a link to a style sheet. So now our page is loading a style sheet. CSS stands for Cascading Style Sheet. And what it is what you're trying to do when you use a style sheet is separate the way you present the data that's in the HTML and separate that into a separate file. And the HTML is the information you want to render, but how you render it is primarily controlled through CSS. That allows you to change the CSS for different situations. So especially useful when you're doing things like making it work on all the different browsers and all the mobile devices and everything else. You can use different CSS tricks to make that happen. Here we've added a button. Okay, so there's a button object. So we've said we have something called a button. That tag is going to make a little button for us. We've gave it an ID, so then we can identify that piece of code. And the thing is, all this code goes into a thing called the document object model, or here called the DOM. And the DOM keeps all this stuff as like an object. So I can tell the DOM to go look up and find an item in there for me, and specifically by ID. And I'll show you that in a moment. So we say it's a button and it's a type button, and we give some text that says click me to display date and time. And then down here we have a paragraph tag, which we say is ID is date label. So we have a paragraph tag on our DOM now that's been specifically ID'd as date label. And then lastly, this is load script. So we're loading some JavaScript. You can put your JavaScript right in your web page. It's not recommended. It's better to keep it external. So that's what we're doing here is we're telling the browser after it renders this page to load this JavaScript, and as soon as it finishes loading, it'll run it. And I'm not doing I didn't use jQuery and some other things here to keep things super simple. So I'm kind of relying on the fact that the browser will load this last. It's not really a guarantee, so there could be timing issues. There's another way to do it. You can say body on load and have it run your JavaScript functions from there. Just doing it this way to stay simple, it works most of the time. So here's what the CSS looks like. And if you remember what the page looks like, you'll see here that the background color is set to powder blue. And the editor is doing a nice job. It recognizes that this is CSS. And so it's showing us the color that we selected. We said that the title, an H1 tag will have a color of blue, and a paragraph tag will have a color of red. That's all we've done. We've specified that in the CSS file. If we go back and look at the web page, you can see that that's why the background is the way it is and those colors are the way they are. Okay? Not particularly pretty or anything, it's just meant to be a demonstration. Now main.js is right here. So what happens when the browser reads this is it says, okay, I have a function named main that has this code in it, and I have a function named onButtonClick that has this code in it. And then it says, I have a call to a function called main. So it's going to read this file and process this data into code, and then run the main function, because that's the last thing we'll tell it to do. And so main is this function right here. And main is very simple. It says we have a variable called button element to which we're going to assign document.getElement by the ID date button. If you remember, we created that button, we gave it the ID date button. So now the document, the DOM, is going to find that document for us, that chunk of the document, and give us a reference to it stored in button element. And then we're going to say button element add event listener. So this is a method on the element itself. We're asking the element to add an event listener. And the event listener is called click. And when click happens, we want it to call onButtonClick. So there are lots of different kinds of events in every kind of thing in HTML. I mean, in the DOM. And so this one, we're just telling it to add us a click event. All right? So there's key down, key up, mouse over, mouse out, mouse in, focus, blur. There's a zillion of them. Click is the one we care about. And so when click happens, it's going to call this guy. onButtonClick, because that's what we asked it to do here. And then what we're going to do is we're going to grab this line of code. It says, okay, I want a reference to the element called date label. Remember, we had a little paragraph tag called date label. So now we're going to get a reference to that, and then we're going to set its inner HTML equal to date. And that's effectively like saying, this is what you have inside your tag. So if we go back to the index, right here is the date button, right? And here's date label, and inside a date label is nothing now. Okay, there's no information inside the paragraph tag. So what we're going to do is inject into it the date when somebody clicks the button. So let's look again at that. So we get the handle to the button. We tell the button to call our onClick method when somebody clicks it. This is the method that's going to get called when somebody clicks it. It says grab the element that holds that we've named date label and change its inner HTML to the output of the date function. So we'll go back and look at that one more time.
And the date is a Java function.
Date is a Java function.
JavaScript.
Yeah, JavaScript, yes. So if I refresh this page, okay, then I click that, the date appears. So that's the simplest kind of JavaScript test I can think of.
So can you go back to the index page for a
Sure.
second? I have a question. So, oh, that's
that's
not the
wrong.
page, that's the wrong one. So right there where you have the beginning of the paragraph tag and the end tag, if you type text in there like today's date is, will that show up when you,
It's gonna be erased when you hit the button. Yeah.
I think, yeah, it'll get replaced.
Yeah, we'll show that. We'll save it. So that should show up in the editor, I mean, on the page. So Carlos asked, you see that?
okay,
Now if I click this, it's going to replace it with a date.
oh, okay.
Because we could do it in pin. You can say plus equals.
Yep.
And you can also call a pin.
Okay.
So if you wanted to add it to none of that, you could. But it's all basic JavaScript stuff. You should study JavaScript. It's actually fun to look at. The bad thing about JavaScript is it's very easy to make mistakes that don't show up until somebody twiddles your code the wrong way. It's not as safe as like C# or Java is in those respects. It'll let you do all kinds of silly stuff that's bad. And unfortunately, you get away with it.
It's a foot gun.
Yeah. Yes, it's a foot gun. There's a good description. So that's that. Is there any questions on step 5? Am I going okay so far?
Mm-hmm.
It's entertaining and informative?
Mm-hmm.
So I believe the next step is going to be to do some stuff with MQTT, which is what you're all here to see. So now we're going to add the MQTT library. So I say open step 6 in your editor, open main.js in your editor, indexing, I say in your editor, what I mean is in your browser. So I'm going to go ahead and open step 6 here. Okay, so now step 6 is there. There's not much to see. And I'm not going to jump ahead yet. Edit the MQTT address to point to your MQTT broker. Edit the variable MQTT client ID. So these things, this is main.js. So again, I'm staying with the convention of loading a main.js file. Let me go back to look at the index real quick. So right here, you see this is the new page. And what we've added is a new line of script here that says that there's a source for script that's at a CDN. That's, if you scroll all the way to the end, it's MQTT ws31.js, which translates to the FAO. I don't know how you're supposed to pronounce it. FAO, the FAO MQTT library version 3.1 for WebSocket support. Okay, so WebSockets is another way to talk to a web server. In web application, when you write applications running in a browser, you can't open a socket connection. The hardware devices actually talk to MQTT through a TCP socket. And but in a browser, in the current state of things, it's considered a security risk to allow you to open an actual socket. So you don't have that. But what you do have is a web socket, which is kind of a promotion of the HTTP protocol that allows a two-way TCP connection with the server directly. Okay, so we're going to be opening the connection up using that protocol, talking directly to the net to the broker. The broker is Mosquito running on Austin IoT server. So we're going to open a WebSocket connection to Mosquito and use that to communicate as if we were a device. We pretty much have all the same functionality. It's just done over a WebSocket instead of a TCP socket. WebSockets are a pretty awesome thing if you need to have real-time communication between an app and an application running on the server or in the device, wherever. So main.js got a lot more stuff in it all of a sudden. So in the instructions, I tell you to come down here and change all this to match what you want. So the MQTT address, this is where the broker is. Okay? So this is pointing at our current broker. This here is your client ID. It needs to be unique. If it's not unique, it'll kick you out. So I don't know if you remember the first Kickstart. I had trouble because I had used the same name in 2 places. And so when I started one up, the other one would die. So you need to make sure this is unique across any connection you want to use. 883 is the port for WebSocket connections. That could be different on other servers, but 883 is the standard port. I have a variable called MQTT connection. It's just a place to store the connection object itself. I have some options here. The onConnect and onMQTT fail, those are event handlers that are set up via the options object. It's a little confusing if you don't know JavaScript, but basically we're creating an object to store these options. And some of the options you may or may not have to specify as username and password, depending upon the broker. So in our case, we don't need to specify that. So then here I have a prefix. This prefix is important because every message my software sends, in this case, to the broker, going to have a topic, which is like the name of the message. And what you should do is create a prefix for everything you do. And when you're doing an application, if you're making a temperature sensor, make it Bill's temperature sensor. Something so that it doesn't correspond to overlap with somebody else's, because your messages will screw up their systems and vice versa. So this needs to be unique to your application.
Hey, Dave?
Yep.
Is that where you could also specify a hierarchy of topics?
Yes. Yep.
Like,
So that's what you need to do. Is the normal standard is you can do anything you want with the topic, but the normal standard is to use a hierarchical structure. So you'd have your project name / your message name. So if you're doing lots of different projects, you could have your domain, your name, your project, and then your message name. Whatever, but use slashes.
then would that string in its totality then be the topic
Yes.
for your subscribers?
Yes.
Okay.
And the reason you want to follow the standard is if you use the slashes like a directory structure, then there's wildcards that let you subscribe to all messages and the subgroups and things like that. So I talked about the wildcards in the first Kickstarter.
So an example of that would be like building 1 / 4th floor / temperature sensors or something.
Yeah.
Yeah.
Yep. You could say Dell / building 1 / temp sensor / and then updates if you want. Or you could say I want all sensors on building floor that's in temperature. So like we said, you could have Dell building 1 sensor temp and then update, which would be the value, right? So then you could say Dell star / update / sensors or temperature, whatever. There's ways to grab whole sections. You can say everything in this tree that also has this subordinate tree. So you can get very fine resolute control over the way you handle with your topics. If you follow this hierarchical structure, you can subscribe to all the temperature sensors at Dell, only the one specific temperature sensor, the ones in building 1, the ones in building 1 and building floor 3. You can have any kind of arrangement you want. If you follow the conventions, and then the messages will be delivered to you, only the ones you're asking for. You can say subscribe to everything and figure it out, but then you're going to be flooded. And if you do that on a public server, I think I said last time, it'd nuke you from order. Because you instantly double the load on the server just by subscribing to all messages.
Yeah, and we do that too.
So what's going on here in the code? Now that we get into the code, we're actually saying, okay, let's initialize our connection using the payo MQTT client. We specify the address, the port, and the client ID when we set it up. So this is pointing to our server. This is our port, and this is what you use to identify you. Then we're adding a couple more event handlers that you can't add through the options. I would have added them all through options if I could have, but they don't let you. So once you have the object, then you can call these. You can set an on connection lost, on message arrived, and on message delivered. These event handlers will be triggered, and I'm saying use these functions, on connection lost. So my convention is use the word just like they're doing here, on. So all my event handlers are on MQTT and then the event name. So these methods will get called when we lose a connection, when a message has arrived, and when we deliver a message. So I subscribe to them, I set them all up, and then I tell it to connect with our options. If you remember, our options also add the connect and the fail. So after that happens, we supposedly magically get connected if it's possible. If it's not, you're going to get a fail. So here I have an event handler for connect, and I just say, okay, we connected. Then I subscribe. So here I'm saying subscribe to my topic prefix plus /#, which means this code is subscribing to every message on the server that's prefixed with my prefix. Okay, and my prefix up here is UC Hobby Web.
UC Hobby hobby, yeah.
Yeah, oh, it's UC Hobby, okay. So give me every UC Hobby message. The UC Hobby web is my client. Okay? So then here I create a test message. And so this test message has the payload, hello MQTT world. Okay? And then we have to go through and set some things up. It's a little funky that the constructor doesn't take the topic. It surprised me. I looked, and it apparently does not. So I get to specify the topic, and they call the topic destination name. So the destination name is my topic prefix plus /test. The QoS, I talked about that in my first presentations on MQTT, but that's a quality of service. For now, just use 0, study it. It affects a guaranteed, think of 0 as like UDP. If you're familiar with it just means send it, and if it gets there, it gets there. Kind of. It doesn't mean, it means don't sweat. Look, I think that's what I said. Don't sweat. And retain is a critical thing. You want to be very careful about using retain. But what it does is it stores a message on the server so that as soon as somebody else subscribes to anything that will receive that message, they'll get it immediately. It's useful for storing configuration data. If you had a temperature sensor that turned itself on and off to conserve power, you might send its temperature data as a retained message. That way when you run your app to check it, your app gets the temperature immediately, the last one that was stored on the server. So that's what it's for retaining messages that get delivered automatically. And then finally, we send it. Okay? So real fast, I'm gonna go ahead on, I have a bunch of other handlers. Fail that says, hey, we had a fail. And if there's an error message, we print it. And then connection lost. If we lose our connection, we just say we lost it and we print the error message. When we get a message, we'll print it out to the screen, to the console. I'm going to show you this in a minute. When we deliver our message, I also display some details about that message. And so all of these are functions that are declared and end up being used directly or indirectly by main. Okay, or by its callback. Almost all these actually are callbacks. So the MQTT fail client will be calling these things as things happen. So now we got main, so it runs main, which goes through and sets things up and builds a message. Okay. Well, we set things up here, and then when we get connect, that's something to remember. You don't want to just go talking to the server right here because you're not connected yet. You have to wait for that to happen. So it could take a second or so, and when it does happen, this gets called. And when this is called, this is the time to do things like subscribing to messages and sending and hellos and stuff. After you got connected, when you get the connection to that. Okay? So now let's go back to the JavaScript, to the web page. And I'm going to open the shortcut to get to the debugger tools is to do an inspect. And so this is the debugger built into Chrome. And it's a very good debugger. It shows us up here we're seeing our elements. We have a console. We can look at the source code. So we can go over here and look at main.js and see the code that we're running. So this is our code. You can actually set breakpoints. I can say I want a breakpoint and I'll set it right there. And when I rerun the code, it would break right there, and I can inspect the variables. This is all built into Chrome.
What was that inspect?
Just right click.
Okay.
Right, what you're doing when you say inspect is it's going to take you to the element view and show you the element that your mouse is on, so you can see what that element was and what its CSS styles and all that stuff are. Then you can come up here and just change it. I have to tell you in the example, switch to the console. So this is when you say console.log. You look in the JavaScript code over here for like on message arrived, I say console.log and I print out this string. And the string contains the topic and the payload. Right? So that's going to come out on the console over here in the browser. You can see it happen. But I'm just going to rerun the page. Just click refresh. And so the first thing you see is it says on MQTT connect. All right, and if we go look at our code, we can see that that there's a handler for InConnect, and there it is right there, I printed that out. So that happened. And then next it says TX, UC Hobby /test, hello MQTT world. And then you see RX, so we received the message we sent. So if you go look in the code, we've got a connection lost. But I'm not going to sweat that, I'm going on the one that happened. So, on MQTT Connect here, we said, subscribe to everything with our prefix. That's why we received the message we sent. We told it to build a message with our prefix and /test. So that's the message we sent, right? So if we look back at the code again, so there's the TX where we sent it. So when we sent that message, it triggered a callback to say we just sent this message. And there's printed it out. And then because we were subscribed to receive messages just like the one we sent, we received the message as well. Okay? Does that make sense? So what we've got now is we've got a web app that actually can connect to the server and send and receive messages.
David, could you click on the network tab, the inspection tools, and clear that? To the right of the, yeah, there you go, and reload your page. Does it show your AJAX calls in there?
You see these XHR, this is the stuff talking to the messages going to and from the broker.
And I think if you click on one of those, you can see what you sent and what you got back. No, sorry, go. You have to click on in the first column. If it's
Or hover over it.
and okay, so I can't quite read that from here, but is that the information? Is that what your request was? And then
It's definitely a website request, but it doesn't show the content.
okay.
That,
Well, it's showing you the response, not the request.
yeah.
There's another tab that will show you the replies.
Oh, headers. Yeah, you got to be in the headers tab. There you go. And then I think to the bottom. I can't quite read that from here, but it's volumes and volumes of information in Chrome inspection tools. You can see everything.
Be careful what you wish for.
Yeah. Bless you.
I don't imagine it's in there. Anyway, so, alrighty. So we're going to continue on. Everybody up to speed where I'm at right now? No problems? Still interesting, still look good? Need to keep going? Okay, so to walk through, we use the JavaScript library called FAO. That's an Eclipse project library. We use the CDN. I should explain real quick what a CDN. Does everybody know what a CDN is? Okay, it stands for Content Delivery Network. You know that your browser, when you ask it to retrieve a page, it has a cache. So it looks to see if the file you're asking for is in its cache. And there's some negotiation that can happen with the server where it says it's changed or not. So what a CDN is a place on the web where we store files, like the JavaScript files, like jQuery and these things. And if you go pull it, if you use that in your web application, and you say, go grab the file from the CDN, what's likely is that that person, the user, has visited other web pages with other instances that also loaded the exact same file from the same place. And because that's true, it just grabs it from the cache. So now what you're doing is by allowing what the general community is doing is they're putting the files in a centralized location. Google has a big CDN, for example. And if you pull it from there, when the guy goes there and the first time he'll pull the file, so Google has to supply it. Then sometime later, the guy will open another page with another app that uses jQuery. He'll try to receive the same file from the same location because he pulled it from the CDN. The browser will go, oh, we already got that file and just doesn't have to draw it again.
The other thing about CDNs is they have local caches at your ISPs.
Yeah.
So it's more network friendly because it's closer to you network wise.
They're optimized.
Akamai, Google, and a bunch of the others all have stuff that is geographically closer to you network wise.
One downside to CDNs though that I've experienced is if you have any kind of like mission critical kind of application, using a CDN to get some file content every time puts you at risk of updates to the files that you're accessing, breaking your application. So
Depends upon the CDN and how good their caching is and how they can expire their cache.
Yeah, usually the files, when you pull up CDNs, have version IDs built into them to try to prevent that. But yes, it could happen. There is a way you can say, give me the latest, for example. Instead of saying, give me version 3.1, give me the latest. And if you do that, then it changes on, you can break a code. So ideally you want to say, I'm not going to say it's not a good idea to pull the latest. You just need to be, diligent in your development. And not pulling the latest and leaving things alone means that you're pulling an old version which could have some sort of security flaw. So, I don't know, pulling the latest and dealing with the fact that your program crashes because you have some incompatibility may be better than pulling the old one and risking, forgetting about the application and creating a security risk.
not if your app is generating $20,000 a minute.
So, trying to understand this, so the page that you created that has the button on it, for example,
Yeah.
when you go there the first time, it goes out and it pulls that page from the server, right? So now at that time, does it copy that back out to the CDN thing?
No, CDN is read only.
It's read only.
But see here, look at this line. So this line says it's got that complicated line of stuff that says go to the CDN, okay? CDN for js.cloudflare.com.
Oh, so that's where it's pulling the
file.
the information that for the page.
And so if you were to if you had been using your computer and doing stuff that involved MQTT, there's a good chance you've already loaded this file some other time in some other application, recent. And so when you visit my page, your browser will just pull it out of cache. And if you don't have it, your browser will go out and ask for it, and the system will pull it from a location that's local to you.
How does it know if the one that you have is the latest versus the one that's there?
Well,
The
a couple
date
of ways.
version number that's in the...
And also the date on the modification date on the CDN versus the modification date on your cache.
Servers and clients do a little bit of negotiation on things like this. So
Okay.
what happens is the client says, the browser says, I need this file, but effectively it says, I have this, and the server says, I have a new one.
Okay.
And then you say, okay, well then give it to me. So that happens, that's kind of a magic piece that's trying to lower the bandwidth utilization on the net for files that can be large. These files aren't typically very large, but they're minimized. So because they're minimized. All the extra space and stuff is removed from this. Actually, the one I'm using here is not the min. But there's a version of that that's .min.js that's going to be about 5 times smaller, maybe even more. And they can also compress it. They often will compress this automatically. So you'll get a zipped version of the min file. It'll be a teeny little thing. And then it'll expand to this giant file that gets compiled in your browser. And again, that also has to do with the CDN stuff. If it recognizes the files in the cache, it'll use the already compiled version. It doesn't even have to recompile it. So it saves your end some time too. Okay, so that's just a quick, brief thing about CDNs. We talked about console log already. We use strict. If you'll typically, I try to remember to do it always. I believe now with the new ES6 stuff, it's a default to use strict. I don't even know how you turn it off. But use strict is me telling the compiler, which is in Chrome in this case, to be critical of my code. If I try to use a variable before it's declared, do a few things that a modern language will actually generate an error for you. You'll get an error. So it doesn't make JavaScript as good as .NET or Java itself, but it helps a little. So it's worthwhile to put it in. So that's why it's there. This is just a note to the compiler. It's kind of got a weird syntax. They just shove in the top of your file this comment that says use strict. Okay. In ES6, in the new stuff, I believe it's default. You have to turn it off if you want compatibility. But I'm not positive about that.
It is.
So what else do I have? We talked about the Chrome debugger. We talked about this other stuff. We brushed on all that. So those of you that know web development in here, am I missing something that I should say right now? Some particular part?
I was curious, oh,
I
sorry.
just had a question, is the asterisk any kind of wild card in this too, or just the?
No, there's a pound and there's a point. I should say, I don't think so. I've used a pound and a dot.
Asterisks and Node are long.
Say again?
Yeah, they count as long terms.
I can't understand.
In Node, they count, asterisks count as long terms.
No, we're talking about the topic in MQTT.
Oh, okay, sorry.
So I don't think so. My guess is because I think I've used an asterisk by mistake and it didn't do what I expected.
That's
So pound is more like asterisk.
Strange you did it that way, because everyone's used to using an asterisk for a wild card.
I think asterisk is,
Could be, but my memory was I tried it and it failed for me. So step 7, we're going to actually get down to where we're actually playing with hardware finally. All right. So in step 7, I tell you to program your ESP with some test code, and the files are in step 7, and build a test circuit. If you're using a Node MCU, and I think the Huzzah and a few others, they have the 2 buttons on them. One's reset and one's the GPIO button. And so what we need is the GPIO button, and the other signal that we need is the LED. So I've wired them up external too, but they're on the board, so you don't have to actually wire anything unless you're using like an ESP01 or something that doesn't have the extra I/O. You'd want to wire them up if you want to be able to see this work. Okay. So at this step, I'm assuming that you've already finished the previous quick start. So you have a development environment, and you know how to write code and flash it into the device. And so we're just going to start kind of from there. So I say save, compile, and flash your ESP. Verify that each time a button is pressed, the LED changes state. I'm going to walk through the code. I'm going to go ahead and do this step here while we're here. That if I press the flash button, the LED changes state. Turn off, and turn on. This button works too. It sometimes bounces. It needs to be debounced. So I didn't want to go into debouncing. So once more, the LED here, I press the button. If it's on, it's going to go off. If it's off, it's going to go on. So it's changing state, which is what we said to do in the code after we flashed it with the code. And I'll show you the code now. So this is the code that's in the ESP266. Again, this is just like Arduino. If you had an Arduino with an Ethernet shield or something, it would pretty much be the same code. Be the same code on lots of other devices like particles and things like that as well. It's the generic type of Arduino libraries. So there's a bunch of stuff going on here, but here's where we're loading the ESP, Wi-Fi, and the pub sub client. We already know all about that from the previous quick start. So that's just getting us set up to have a library of code to do those functions. Then I've got a whole bunch of functions defined here. Actually, I think this particular piece of code is missing one update from my repo. I believe I commented every single line whether it was necessary or not. But in any case, connection update. What I did, I'm just going to scroll past all this for now. So the setup function. All right. So we're going to set the LED pin to output. We can go back and show that I have defined a bunch of constants here that have to do with the I/O on the board, so that I can use nice names instead of magic numbers. So the setup function in Arduino, as you all know probably, is the setup runs once at reset. So this is set up the system. So we're going to set the pin to output mode for the LED, and we're going to turn that LED off. So after reset, the LED will be off. So it'll match our state variable because we keep track of the state of it as well. We assume it starts up off. We start the serial port at 115.2 and we delay a little bit. This is just letting the serial port get up, flush out any garbage that might have occurred. The ESP does puke out some random looking garbage when it first starts up. So I tend to pump out a bunch of carried return line feeds and then some text. And by then, this will give you a clean display of your time. Otherwise, it may end up on the end of a bunch of garbage, or there could still be framing errors still occurring. So here we do get connected to Wi-Fi. So I just report that I'm going to connect to Wi-Fi and remind out the SSID. These things are things you have to set up. Okay, I guess I forgot to start with this. Here's the stuff you need to configure. So your MQTT ID that you want your device to use, your SSID you want for the Wi-Fi connection, the password for that Wi-Fi, the MQTT server's address, and your topic prefix that you want to use for all your messages for MQTT. It needs to know the port, and note this is a different port because this uses TCP to connect to the broker instead of websites.
Now, the topic string that you use needs to syntactically match. It needs to be identical
It
to
needs to
what's...
be binary identical.
Yeah.
So case and everything matters.
So should that be UC Hobby Web up there like the other one?
Depends
was?
on which stage we're at. But this is what should be working. So, quick start didn't, at every step things have changed. So I didn't go back when I decided to use this instead of UC Hobby. The reason is I'll probably use UC Hobby for real for one of my projects. And so I wanted something that people could, if they brought this up and brought it up, it wouldn't mess up my stuff. So I gave a different one in here, so that if you're lazy and you don't fix it, at least it doesn't mess up the stuff I'm doing.
Sure.
Does that make sense?
Yeah.
So here we got another object that we're storing our client in. Let me go on down here and say, we'll connect up to Wi-Fi. So this is the command that starts the Wi-Fi process of getting connected. And then we also set a callback here for MQTT to tell it that every time a message is received, to call this function called onMQTT_message. And one thing you'll note, in my programming, I very much convert everything to events. So I like to create discrete functions that perform particular tasks and isolate them out of other places so that you keep functions small and you just describe what you're going to do at each point. So some setup stuff here, and then we go to loop. And so if you see my loop, I've only got two things happening. One of them says connection update. The other one says button check. So actually it was a mistake. I should have called that button update. Didn't follow my own standard. But what an update function for me is it means go out and do all the polling required to trigger events. Okay? So connection update goes and checks all the statuses. It checks to see if I got MQTT, Wi-Fi connection, MQTT connection, if they've changed states, things like that, and it throws events. And the events are called from this function, so they're not on a separate thread or anything. So it's thread safe. But I do that in the loop. So what happens in the loop, each function that I put in here returns immediately. It just does a quick check and then returns. So it doesn't spend a lot of time. So loop is tearing and ripping through real fast constantly. So all these checks are done at a high rate. And then when there's something to do, the function gets called via call, effectively via callback. So here's connection update. Looks like a big mess, unfortunately. But what it's doing is just saying, if the Wi-Fi status is not connected, and it was not connected before, excuse me. If the Wi-Fi status is connected, we are connected, and we weren't connected before, then we have a new event. We have a new onConnect. So we call onNetConnect. Okay? Here we say, okay, we're not connected, but if we were connected, then we call disconnect. See what I mean? So all I'm really doing is checking the status and throwing events. So if I see a change in the state of the connection, somebody's going to get called either on connect or on disconnect. For net, and the same thing for MQTT. There's an MQTT and an MQTT, connected and disconnected, and then I maintain a status so that I keep track. And the MQTT library needs a call to do its processing. So the loop is what they call their update function. So they run through and do their polling work in there, and then they return. So this large white space function is just doing a bunch of checks, and it will execute very fast. It looks big, but there's very little going on. It's just a few conditional checks, and then some calls if something's changed. Then here's the next function that was in the update loop called button check. It's a very similar function. It says if the button, we read the button right here, and I'm nodding it with the not expression because the button is active low. All right, so I'm saying read the button and then invert it, because if it's low, I want it to be true, which is 1. So button value represents the state of the button. Then I say, is the button value equal to the button state? The state is what I'm storing as the state of the button. If it's not, then something's changed. If the button's down now, then call on button down, because that just happened. If the button is up, then call on button up, because that just happened. Does this make sense?
So, I know that the loop executes that at lightning speed.
Yeah.
So, but what that code does is it relies on the person altering the state of the button not too fast as to happen in between the two
No.
ticks of the clock.
No,
No? Okay.
no. When it reads the button change is when it's going to trigger the event. So there's no way to miss that change.
Okay.
Technically, if you could make the button go high and then low again fast enough that it was in between the reads,
Yeah.
then you'd miss it.
That
You'd have to do
was
in
my
about 2
question.
microseconds.
That was my question. Okay.
So it's not debounced. I didn't debounce it here, but debouncing is an advanced concept, which we could go into, but I just assumed that I'd be okay. I believe they have some capacitors or something on this button. That's the reason it doesn't bounce, and this one does. But I don't recommend using a capacitor for debouncing, but code debouncing I'm not doing here. I'm cheating and just taking the easy way out. But so it is possible that you could get more. The worst thing that could happen, and that's what does happen when I press this button, is that it fired twice. You see that? The light was on and it's still on because it went off and came back on. So what happened is the switch bounced. So it got a signal that said it was pressed, and then it got a signal that it was unpressed, and then it got a signal that it was pressed. And all that happened in very short order. And my code is running, in the microseconds. It's very fast. It's 16 megahertz.
Can you add a wait statement?
Yeah, well, there's different ways to handle it, but the right way is to debounce. The right way is to watch the state and see a change, and every time the change occurs, you start another timer. It has to maintain the current state for a period of time before you say it is in fact changed state. That's debouncing. And I don't
So it's a pseudo wait statement then in software.
No, it's not a wait statement. It's a kind of filter. What you really do is you read it and you check to see if it's changed state. If it hasn't changed state, then you continue reading. On a fast time. Generally speaking, it's quick. And if a certain amount of time has elapsed, if it hasn't changed state for this period of time, then you declare that it's got this state. Okay? And so now that's a decoupling or debouncing that you do in front of the state detection that I'm doing. So that the state of the button, now here I'm just reading. I'm just reading it right there. There's no debounce in that reading. But if I was going to debounce it, what I'd actually do is create another function that actually debounces that button and returns the status of the button as it's on the hardware by monitoring its state over time. That's just the way your keyboards and your mice and all these things have debouncing built in so that they don't double button. The buttons don't double bounce and click multiple times. I cheated because I could get away with it. I wanted to stay as simple as possible. So again, what's happening here is I'm monitoring the status of the button, and if I see a change in state, I call a handler to handle that change. Doing this makes it very easy to control what happens in your program when things happen. Like when MQTT connects, it's a good time to subscribe to your messages and send your hellos. right? When somebody presses a button, that's when it's time to do something because of the button, like change the state of the light. And putting it in that loop, you know, causes it to be very responsive because the loop is ripping through and it looks like real time. It looks like I can, when you write the code, that I can send and receive messages, handle the button presses, control LEDs, neopixels, read sensors, do all that simultaneously. It all appears to occur simultaneously. And there's very little loss over an OS. When you have an operating system, you can use threads to make things appear to be occurring simultaneously. They're really not happening simultaneous. What's happening is the processor's switching fast. And so it's doing one thing at a time, and it's switching between them a lot. Same thing is happening here. In fact, I'm just doing it in a messaging, in a loop, in the idle loop. It simplifies code and allows you to do some really complex things very easily. You just have to learn to do it that way. So here's what happens when we connect to Wi-Fi. We say connected Wi-Fi, and we say, this is another example. When should I connect the MQTT? It's after I get Wi-Fi connection. How do I know when I have Wi-Fi connection? Because I have an event that says you got connected. So that's what's happening here. I got connected, and I connect to MQTT. A disconnect happened. I just reported it. And things went bad. We lost our connection. On MQTT connect, I say we got connected, and I build a prefix which says my prefix and everything under it, right? My prefix / pound means anything in my prefix and any message as a topic that matches my prefix in a hierarchical way comes to me. And then I call subscribe. So that after I do that, from this point forward, every time anybody sends a message to the broker that matches my topic, I'm going to get the message. Then I create another topic, and I send the message to test, and I say I'm alive. And so that's what happens when a connect occurs. As soon as a connect occurs, I subscribe. Well, let's back up and say, when I get a Wi-Fi connection, I then connect the MQTT. And then when I get an MQTT connection, sometime later, I subscribe to my message and I send a test message. Here I have a disconnect for MQTT. And then here's what happens when we receive a message. And we'll just look at the first part of this for the initially. So what happens, the first thing I do is I print out the message. So let's go look over here on the Arduino environment. So this has the later step loaded into it, so there may be some extra debug information coming out, but it's just an addition. Save us the time of waiting for it to program. So there's some of that garbage I mentioned, you see at the top. And then there's our, after our return line feeds, it says connected Wi-Fi MQTT connected. So it should have connected via my phone. So I'm going to reset it to something. Didn't happen. Be my luck, it doesn't. Oh, there we go. So as you can see, what happened here is it connected. It said it came up and it said it's going to connect to iPhone Alpha, which happens to be my iPhone. It's got an access point set up. And then it said connected Wi-Fi and MQTT connected, and it says connected. Message arrived, I'm alive. Okay, there's another thing going on in there we'll get to later. That part about the VDC and stuff, that's some later code. That in addition to what I have here, I added more in the next steps. So in addition, in the very simplest thing, think in this step. The next thing we have here is that there's some complicated stuff here. I'm creating a string that I'm going to use for manipulating my payload. The payload, when you receive it in the event handler, is a binary buffer. So generally that means it's got ASCII in it, but what it may be is not terminated. The buffer comes to you as a buffer address with a link. So you can't assume it's terminated. It may or may not have a 0, and it depends on how it was sent. Because from an MQTT server standpoint, a broker standpoint, it's just a chunk of binary. It's not going to stick a terminator on there for you, not necessarily. So to be sure, I have to go through some gyrations here. Your first inclination is to say, why don't you just go to the end of the buffer and chop a 0 in? You can't, because the buffer, you don't know how big it is. you're given a size, and it may exactly be that size. So if you drop a 0 in on the end of it, the 0 terminates, you might be overwriting memory. So you can't do that. And the string object, in a normal, if you have a full STL library, standard library form C, you have a method that will build a string from a buffer. You can specify the size, and it'll do it perfectly. That function, unfortunately, isn't available on the Arduino. So what I do here is kind of cheesy. I just say, okay, fine, I'll build the string one character at a time. So I created an empty string right here, and then I walk through all the bytes that were delivered to me in the message right here. Here's my payload and my length. So I walk through the entire thing, pumping them one byte at a time, and casting it as a character and appending it to the string. It sucks that you have to do it that way, but it's safe. It's simple and safe. So now I can print it, because I actually have a string that I can print. If I had printed that payload before that, I could have got a huge amount of garbage, because it could have printed some amount of memory until it finally found a null. Strings in C are supposed to be terminated with a 0, with a null. So I guess I'm harping over this again and then, just warning you guys that this is not a string of characters. It is a byte buffer. So to be a string of characters, it has to be terminated with a 0. No, you don't know if it is or not.
Without embedded nulls.
So, yes. So that's true. If it was binary data, you need to handle it differently. You can certainly do that in C. It's a great way to do things. Very efficient. Create a structure, specify all the components of the structure, send that as your message. Now that's binary, and you certainly have to use a size. And it could be that there's nulls inside the data. You can have zeros in the data. Right?
So does that mean that I length then is always divisible by 8?
No, it is in bytes.
Oh, it is in bytes.
It is in bytes.
Okay.
So you have a byte buffer, pointer, payload, and then you have the length of it in bytes. So really every byte is, because we're sending the messages, every byte is ASCII.
A character.
It's UTF-8 we're
Okay.
sending. So we can just say that it's characters and we're okay. Just dealing with the fact that it may not be terminated is all I'm doing here. And the other reason I want to put it into a string because I can do comparisons on strings. If you're using character arrays, you have to use standard C functions like a string compare, things like that, to do the comparison. But if you're using a string, you can actually just say, is the string equal to is this string equal to the character array on? And if it is, it'll be true. So this makes the code easier to look at. It's the reason why I'm listed. And string gives you lots of nice functions and stuff that are useful. So I'm saying that if the payload, so if I receive a message that has a payload equal to the string on, then print on command and turn the LED on. If I receive a string, a payload with the string off, then print that we got an off command and turn the LED off. Okay? So that's all I'm doing in the message handler. I'm not even checking the topic.
So then are you restricted to just ASCII, or could you, since it's just boils down to bytes, could you also send like UTF-8?
Well, UTF-8 is a way to encode data, so we're encoding ASCII and UTF-8. That's the way you typically do it. So we've got ASCII UTF-8 is what's actually coming in, because that's what we sent. But we could have sent binary, anything we want.
Yeah.
And it's the most efficient way. If you're writing a program that's doing something and you're using C, it's very easy to create a structure, C or C++. Other languages like Java and other things, it's pain, because you have to create buffers and manipulate in a way that's a little bit more difficult, but safer. Okay? But in C, it's very easy to create a structure and define it. If you're going to send data from a temperature sensor and humidity and other things, instead of converting it to strings, just store the floats and the values in a binary structure and send that. That's just fine. It's much more efficient if you're worried about efficiency.
Well, if you're using UTF-8, then you're not restricted to English.
No, UTF-8 just means we're going to use all 8 bits of a byte.
No, it's not.
No,
That means you can, UTF-8 means you can have multi-byte characters that are represented in 8-byte forms. UTF characters are
Yeah, yeah.
at 16 or at 32.
I know, but from the standpoint of if you're transporting binary data like a structure, you can transport it as
No, you
UTF-8.
can't.
Okay.
But you
I stand
couldn't,
corrected.
couldn't you code it though to,
If you're dealing with text, you have to, if you're dealing with text, yes, it can be UTF-8. If you're dealing with binary, you have to, you either have to know which endianness it is, or send it as RPC packets, which have that encoded in it.
All right. Okay, so.
sorry, took us off the trail here.
Yeah, that's all right. Learn something. So, so on button down is an event, another event that we saw that I handle. And in the case of on button down, I create a message topic with this LED in it, because I'm going to change the state of the LED bar. And so I'd say if the LED is on, set it to off, and publish it as off with the publish message. So this is a message being sent to the broker with it set to off. And so LED state is set to false for my track, so I keep track of what state I am.
as I can.
So here I do the opposite. If it's on, I'm going to turn it off. If it's off, I'm going to turn it on. Okay. And on button up, all I do is print that the button went up. So if we go look at the over here at the com stuff, you can see that if I press the button, you see that it said down because I pressed the button down, and then it received the message that it transmitted. It transmitted the LED on message and it got received, right? So that's why it showed up. And then when I let go of the button, it went up. Okay? So that's what we coded it to do. So there I sent the off command. Back on. Now if we go to the browser, and if everything's working, go to the step. I think maybe that's the step that okay, it was out of sync when it started. So we'll look at the code in the browser side. But what I'm doing here in the browser is I'm effectively pressing the button because I'm sending an MQTT message from the browser here. So invalid state not connected. So we got some kind of an error that occurred. Always happens during a demo. The presenter doesn't know what UTF-8 is, and then his browser disconnects from it. It's doing it again.
MQTT connection loss. Yeah, and it could be other clients out here
Could be somebody else who's loaded this same code and
trying.
messed with us by kicking us off because they got the same ID. But anyway,
It works.
it works. And if you watch the light up here and the button on the form, it should also change. So it was out of sync there, but on and off. Okay. So now let's look at the code real quick. So this was the Arduino code. Now we're going to go look at the web code that we were just running, which is over here in step 8. So we got the same stuff we had before, except we added a test spot. Okay, which I'm going to show you in CSS that I size. So here's CSS specifying what we're going to do with the tag test spot. So I'm saying draw a box around it, make it this color, make it this size, etc. Right? And then I created two. I don't use both of these, but I created this is a CSS class. Does everybody know what that is? So this is like a rider on top of this says for something named with an ID of test block, use this style. And this says if it also has the class specified of LED on, append this style to it. So this is added on top of the previous one. So when test block, you'll see in the code, when the page renders initially, it renders it with test block because it doesn't have a class applied to it. But then I'm going to use the DOM to apply the LED on class to that object, which will cause it to restyle based on this class. And that's why it turns blue.
Could you show in the in the HTML where classes and IDs get set?
Well, here's where the ID gets set. So this ID is a division. It's called test block. So this chunk of code is a division in the DOM. Okay, so the division just means the chunk of stuff that we're going to identify with a tag called ID. And so when the CSS loads it up, it's going to use this pound means by ID. So testbot's ID is now going to get this style. So that chunk of HTML renders using this style. It has no class specified, so you can add to this. You could right here. You could type in class equals and then put the LED. Okay, but I'm not going to do that. I want it to come up off, not looking like it's on. Okay. Now the code right here, pretty much the same code we had before, except where it's going to change down here in a couple. Well, it's going to change up here too. So right here is a change. We say, give me a handle to the button element, right? Called test bot. Well, I'm calling it a button. It's a division, but in my code I call it a button. And I get a handle to it. And then here I tell it to add an event listener for click, just like I did with the real button. So that when you click on that division, it triggers this event handler. Okay? Now, so here's the on button. So depending upon the track state of the button, right, to keep track of what state it is in a variable called LED state. If it's false, I set the true, and then I send the LED on command. So that's an MQTT command being sent. And if it was on, then I turned off. So all that's happening here is when you click the button, you send the command. Okay, and if it's on, you'll send the off command. And if it's off, you'll send the on command. That's all that's happening. So you're going to go, how come this change in color then? Because it received the message that it sent. Okay, so let's before we get there, let's look at here's how I send the message. So I create a new message and I pass in the string command as its payload. And then I specify the topic as my topic /LED, because the LED command is either an on or off command. And then I set the QoS to 0. And then I set retain to false, because I don't want to store the message. And then I send it. So that function sends the command for LEDs, send LED command. And you can specify on or off as the parameter. And here we're sending. Now if we go back up to on MQT arrived, we get a message. And I extract out of that message the payload as a string. There's a assumption that it's a string in this case. But the object, the message object, actually has a thing that returns it to me as a string. So I get it as a JSON string, and I get the destination name as a JSON string, payload and topic. I print that message out, and then I look at the command. If the payload had on, then I set, this is where the magic happened right here. Element set class, test spot LED on. All right, so that's also a function I've written. We'll have to look at that function. And here, if it's on, I set the class for test spot to LED on, and if it's off, I set the class for test spot to nothing, which is erasing the class specification.
You could have said LED off as well too.
I could have.
You had that.
Yes, but to keep things simple, I just did it this way. I just erase the class. So it's set per the default configuration, which is to show it in the off state. And then I tell it to append the off state style with the on state style. And so that the on state class supersedes the default. Okay? So that's all that's happening here. If we go down here and look for the set element class, here's how that's done. It's pretty simple. I just say document get element by the element's ID, which is the LED state, and then the class name I set to the class ID I specified. And so I just clear that class name. I erase it by setting it to nothing when you do the off. Does that all make sense?
Dude, have you ever talked about the command line tools that come with Mosquito? The Mosquito pub itself?
No, I haven't done anything on that side of the domain yet.
probably worth mentioning here with the on and off, because back here, I can see if you bring up your browser.
Yeah. Oh, you're talking about in the, in my browser app?
Yeah, so
Yeah, they're right here.
it's currently off.
Yep.
Like, I can turn it on from here.
Yep.
Using, so that way you can test your
Yep.
website.
Oh, yeah,
hardware.
I have this up so that, you know, we can talk about this. This is a nice tool. What I would use for debugging is this tool here. So go ahead and subscribe, connect it to the Austin IoT server, and then come over here and you can subscribe. In this case, I'll go ahead and subscribe to everything. And as soon as I subscribe, I got the message that's sitting in a retained slot on the server. So there's a retained slot being used called chat, and the message I sent into there comes out. Now, if we go press the button over here, you see the on message arrived, and the off message arrives, and I can come over here, and if I check here, you see the topic is. We'll just copy this out. We'll put it in here for the topic. And we'll put the messages off now, so we'll send it on. So now I'm going to publish that. And I click publish.
Yeah, it's coming through, but with extra returns.
I hit a return. So it's binary again. So character return is a character. So watch out for that. But you see now in this with this web-based tool, it's connecting to our broker because I asked it to. And I subscribed to all messages with this pound. So now I'm going to get all the messages. When you're doing your stuff, you probably want to put your prefix in here so that you only see your stuff. And then you can see what's happening, see what your device is doing, and you can send messages to it to validate the command and performance of the thing. So we'll send it off now. It's a very useful tool. Okay. Anything else? Any questions with what we've done so far? There's a lot of stuff to soak up. Okay, so we're on step 9 now. Step 9, we add we open the INO file for the Arduino, and we make some changes so that it will read an analog signal, not the Arduino, the ESP. The ESP8266 has a single ADC input that normally operates 0 to 1 volt. Depending upon the module you have, like the Node MCU has a voltage divider on it, on the input to do something. Maybe it doesn't. I have a voltage divider in my hardware. You may have to look at what you've got and figure out how to do it. But in this case, I have a potentiometer connected up across the VCC, across 3.3 volts and ground, so that its output is going up and down in voltage when I turn it off. And I have a voltage divider.
Could you hold that up for a second?
I have a voltage divider on the circuit here underneath. It's hard to see, but that's dividing it down so that it goes in a 1 volt range. So the ADD converter on the ESP8266 can read from 0 to 1 volt. So what I'm doing is I'm translating 0 to 3.3 to 0 to 1. Okay? So that's the circuit. And then we add the code. So we're going to look at the code. So it's pretty much all the same stuff we had before, except we've got some new, we've got a new message we're going to send, the ADC message. And we're going to have a new update, sensor update timer. So we need to read this POP, but I just don't want to read it, every loop through the idle loop. I want to read it every now and then. And the reason I'm going to do that is because what I'm actually going to do is I'm only going to send messages when there's changes. When you have a sensor, you could send updates at some rate. You could say 10 times a second, let's tell them what the pi is. So I could have done that, but it's nicer and more efficient to say, I'm going to look at it 10 times a second. If I see a change, then I'll send a message. So now I can have high update rate, high resolution in terms of adjustment, without having high message traffic. It's called delta modulation. So what I actually do is look for differences, and when I see them, then I update. Then the server side, if you set that with a retain, you know, whenever you connected, you could get the data that would say the value of the sensor is X. It would be stored on the server for the obtain message. And this would update it whenever there's a need to change it. Does that make sense? Well, we'll see that code now. But first I'm going to show you this update timer thing. So pretty much everything is going to be the same, except I have a new function here called sensor update. So we'll go down here and find sensor update. Sensor update, you see it has a current time and an elapsed time, so you can tell it's doing stuff at time. It's got a MS on the end because I'm using milliseconds. It's my convention that variables should always be psi. If they're not psi, you have to specify in the name. So MS means it's milliseconds instead of seconds, which is science units would be seconds. So I don't put feet or inches or anything in my code. It's always meters. It's always a psi unit in code. I only translate it to user units when I present it to a user. So that's just my convention, so I don't have to worry about what my units are. So here I grab the current time in milliseconds, then I set the elapsed time by subtracting it from the previous update, and then I check to see if our time is elapsed. So there's a variable called sensor interval milliseconds. So if it's been long enough, then I grab the current time and put it back into my update time so that I know how long it's been for the next time. And I call on sensor update timer. So this function is really just a timer. It's going to call this other handler every 100 milliseconds. So again, it's just me making things into events. So now here's the on sensor update timer function. So what I do is I read the analog input right there, and then I convert it into volts. And I'm using a function called map. This function uses ints, which is not very inductive. There is a version of it that's that I could have used, but it had another complexity, so I didn't. What I did is I just come in here and say, convert it from the input value, ADC raw, which goes from 0 to 1024 actually. Convert it with 9 being 0 and 998 being the max value. And this is the min and the max on the input, and this is the min and the max on the output that it's mapping to. So the reason it's not 0 to 1024 is because I measured it. Turn the pot to 0, I got 9. I turn the pot to max, I got 998. So I said, okay, that's my range. So I stuffed those numbers in. So those are quote magic numbers. But
It's a factor.
I documented it in the comments at least, so cut me some slack. So then I check, I subtract my previous reading from my, and I do this using the raw binary version of the thing, not the voltage, just because it's simple. And then I check to see if the change has occurred that's greater than 4 steps in the binary. So this is this is 4,024ths of the range of the converter.
On that map function, you said that is the input, is that voltage that you're getting, is that just an integer?
No, actually, well, I guess I didn't finish. This is going to return a value that goes between 0 and 3,300.
But
And then I divide it by 1,000 to get 0 and 3.3.
But the actual value that you read
This-
on the plot is whole.
Yeah, this is an integer.
There's no, you're not, so the granularity of that output is gonna be whatever it would be between 0 and 998. It's not going to expand the granularity to.
No, what we're going to do is expand 9 to 998 into 3 to 3,300.
And then you're gonna divide it by.
And then I divide by 1,000.
So
And it's-
granularity becomes a non-issue.
Yeah. I'm just cheating so that I can get a floating point representation out of this integer function. And so then I check to see if it has changed. So I've got a little window. I don't care about 1 bit. You're going to get 1 bit of noise on your converter anyway. So I give it for a couple of bits. This is 2 bits of noise on the converter. And then if I see a change, I capture the new value and I print the value that we saw on the converter out, just to show you on the console. And then I send a message for the converter. Okay? So the rest of this code is all the same. Well, no, there's one more function. there's the message that sends the MQTT message for the ADC. So you see I take my topic and I apply the ADC to it, and then I send that message.
Is that, I'm sorry, but is that A to D converter on there actually sensitive enough to measure a thousandth of a volt?
Well, that's what it converts to. How many bits of noise it has? I don't know, but I don't see any noise in 2 bits. So it's at least from a noise standpoint, it looks good.
But it's returning a value between 9 and 998 to represent a value of basically 0 to 1 volt, right?
Well, that's a function of my voltage divider. What's probably the case is that there's a little bit of offset noise on the input, so it doesn't ever get to 0. And then when I turn my pot all the way up, it's going to 3.297 or something.
It just seems that the 1,000 seems like a pretty sensitive A to D converter. To me,
It's a typical converter today. 10-bit. It's a 10-bit converter. If you want to go higher than 10 bits, you got to be extra careful. Most people don't understand that. I see people go, "Oh, I'll just slip a 24-bit converter on there." Good luck with that.
You've got 10 bits of precision, but you gotta wonder how much accuracy.
Yeah.
Yeah, but that's always with AD
Sure.
converters. You always have whatever the bits are, plus or minus half a bit at minimum.
Yeah, it's usually a bit and a half.
Yeah.
And that's good because you can use correlation approaches to increase resolution.
It seems like a lot of precision in there. It seems
Yeah,
good.
it's nice. Back in when I was doing lots of embedded work in the earlier days, it was always 8-bit.
Yeah.
Now they're pretty much always 10-bit, and plenty are up into 12 bits. Okay, so let's look at this working on the program over here. So, assuming it still works, as I turn this pot, you see the values. But if I stop it, they stop. So every time it detects a change, it's sending. So as I'm turning, we're sending 10 messages. 10 messages a second. So 300 milliseconds. But when I let it go, it doesn't send any. No need to. It's the same data as it was before.
Oh, it jumped once.
Yeah. Well, it's on the edge of something. But yeah, I haven't seen any problems with that. So so now our web code is the next thing to look at. So everybody up to speed what we're doing with the Arduino here. We're just reading the pot and checking to see if we see a change within a window, converting it to a voltage, and if we see a change, we're sending a message to the MQTT with the value from this pot, which represents a sensor. So, step A. I didn't notice I didn't say 10. You might be
Appendix.
going, why didn't you use 10? Well,
Hex.
maybe I look cool because it looks like hex, but step 10 lexically would be the first step in my list. So I said, I'm make it A. So it wouldn't be the first one in the list, because lexical sorting would have made that first. That's the only reason. So the step A, index.html, this is where some of the new stuff that we talked about is. What we're doing here is we're loading this library here, which is the Google's how you get to Google's library stuff. It's not the actual library, it's their loader for libraries. Okay? So I'm telling Google to give me, I'm telling the app, the browser app, to go grab this library from Google, which is a library we're going to use to load other stuff. Okay? A little confusing, but that's the way Google likes to do it. So now, go to main.js here. We can go over here and I can show you that this is pretty much identical. No changes in the CSS, so no magic here. And then main.js, it's going to be all the same too, up to the point where we're messing with the gauge. So we're going to put a gauge on our form now that's controlled by this pot. And so I've got some data that I've declared globally here. So I've got a thing called the gauge, which is going to store the Google gauge object. Then I have the gauge options, which are details about the gauge. And then I have the data that's going to be displayed on the gauge. Okay? This is not necessarily my structuring, it's what Google has you do. And then down here in the code, here's some new code. All right? It says google.charts.load, and this function, this library chunk, it's called Google. The chunk we loaded will magically appear in your code as Google. So google.charts is Google's visualization chart library. So we're saying google.chart.load the packages gauge. So when it's done, we're gonna have this component added to our available functions. Okay? So it's not like I don't assign it to anything, it's just when it comes in, it's available. All right? And then we're telling the same thing, that when the load is done, because it can take some time, this is asynchronous programming, to call this function called setup sensor gauge. Okay, so to reiterate, the changes to this piece of code, this application from the button press thing, is that we've now told it to load the Google Loader library, and then we told that library to load the packages gauge, and then we've told that library loader to call this function when that library gets finished loading, so that it's available. Then, here we create our gauge. So this is how you create a gauge. What it needs to know is the area on the page, the element name, the ID of the element where you want the gauge to appear. We'll jump over there real quick. In this code, you see right here, I've added below the button that we had for the LED. I've added another division called sensor gauge. And that's what I'm passing in right here. So now I've told the Google Visualization Library to give me a gauge object and work on that particular element in my HTML. And then I'm going to specify the options for the gauge. I want it to be 400 by 400 pixels. I want it to have a max value on the gauge of 4. I want it to have 10 ticks between each major tick on the gauge. And then I tell it, Google uses their own object for managing data for their visualization components. It's kind of a generic way. It handles charts, line graphs, and gauges and everything. Okay, all their stuff. And so it looks like an elaborate thing for just doing a gauge, but it's that way because it's generic and works across all their visualization components. So here I'm creating a Google visualization data table from an array. So they have a thing called a data table. So the data table in this case has two rows. The first row is the title row that defines the elements of the other rows. And Google recognizes the word label and value to represent the gauge label in this case and the value on the gauge. So I'm saying, okay, create me a little data table that has label and value and VDC and 0. Okay? And then here I tell it to draw the gauge. At this point the data is set to 0, so we're just going to we'll get a gauge render with the needle sitting on 0. Okay? So now, at this point, we have a gauge, but it doesn't move. And we have now what we're going to do is move the gauge. So when we receive a message that tells us what the voltage is, we want to update the gauge. So here we have a more expanded message handler. Instead of just using looking for on and off, I actually go ahead and parse the topic. So here I have a switch statement working on topic. And I say if the topic has this prefix and LED, then call the on LED message handler. And that message handler will look at the payload and do the on-off stuff for us, okay? And this one says if it's got ADC, then call the on ADC message handler. So I'm back to events again. I created a handler for each kind of message. And so this on message, all it's doing is parsing the topic to decide what handler to call. So here's the on LED message. Doing the same thing it was doing before, except it's now in a separate function. And then here's the on ADC message. So what I do is I parse the float of the payload. The payload, in this case, is just an ASCII representation of a floating point number. And so I parse it as a float, store it into a variable called sample. Then I use the sensor gauge data object that Google gave me, the data table. And I tell it to set the value in column 0, row 1 is sent. As the VAC. Row 0, column, whatever. That's the way to do it. So, and then I tell it to redraw the gauge. That's it. That's all the new code that there is in this. If we go look at step A, we get our gauge and our button. And hopefully this thing still works. Yep, the button light turns on and off. Now, the gauge, it hasn't gotten a message, so it doesn't know where the pot's at.
Oh,
yet.
good, yeah.
So in case you saw that, but as soon as I move the pot, it doesn't work. Oh, we lost our connection. Whoever's playing with me, please stop. But anyway, so here we can see as I turn the pot, the gauge is updated. It's very smooth, even though I'm not going to be sending messages like now. There's no traffic being used. But when I actually get in here and turn the gauge, it will. Now, if you go look on the on this guy, you see all the messages flying by. So for debugging purposes, we can also fake it and put a message in on our own and move the gauge. But you can see the gauge it's got 10 ticks in between each major, and it goes to 4. So this pot maxes out at 3.3.
That's awesome. So you could also do the reverse of that. You could use like a Google slider
Yep.
and control things
Yep.
on the SOC.
Why didn't you make the gauge go to just 3.3?
Because I wanted to see it. If you do it 3.3 and you tell it to get 2 divisions inside, what does a division mean?
Weird, yeah.
It's very weird.
You
It's
have a
fractions.
major that was 3.3.
So having the major be a full integer makes the minor ticks make sense.
You could do it 0 to 100% or something like that.
Yeah, could have done that. So, but that's your answer. That's the reason I didn't do 3.3. That's pretty much it. That's the presentation. We went from doing getting a web server development environment set up, proving that we could run the web server with Node and the light server, and then bringing up the editors and editing the files, got JavaScript running, wrote an app in JavaScript that controlled the device, changed the device to use to toggle an LED on command via the button and via MQTT. Wrote a web app that represented and did the same thing, and then we took that app and expanded it to in the ESP to read a pot and send messages, and then we did a gauge in the HTML and JavaScript using Google visualization. Is anything about this hard? Do you think you could recreate it?
Absolutely.
Yeah.
Yeah, and the quick start's there. It's got all the information, all the code. And so I recommend you work through that. Go if you haven't done the first one, do the first one. Then do the web one, and then Bob's your uncle. You should be able to do pretty much any kind of thing you'd want with a device, especially with an ESP, using a web interface. So,
Awesome.
that's it.
Thank you, David.